everyone. In this video I will show you how to drawing a graph of a rational function or how to analyze the graph, okay, to showing all the significant feature for this function. The function here, the given function here, f of x, this is f of x is equal x squared minus 3 over x to power 3. The first step here, determine the domain. The domain for this function, this is a rational function. This numerator and denominator, everyone is a polynomial, but here the domain is equal d, is equal all real number except just one value that make the denominator equal 0 is 0. Okay, this is the domain. I think here the next step or the next features here, we can find the vertical asymptote. Okay, asymptotes A. Okay, I think we find the vertical asymptote at values make the denominator is 0. Okay, that's here x equals 0. That's this the value makes this is a vertical asymptote. Okay, good. Also, the third step, we find the derivative, the first derivative this function. This is function is rational function. We can use quotient rule. Quotient rule here, I think here, sorry, maybe write better than this. Okay, to take this is good. Here, this is the numerator x squared minus 3 derivative times x power 3 minus, I think, x squared minus 3 times derivative the denominator x to power 3 derivative here. Yes, that's good. What happened here? Okay, good. Over square the denominator x to power 3 to power 2. That's good. Here to continue, I think, okay, this is the derivative 2x times x to power 3 minus, I think, the derivative x 3x squared times x squared minus 3 over x to power 6, because x to power 3 to power 2 times the power 3 times 2, 6 is good. Here we can find, this is here, I think, 2x to power 4, x to power 4, because here the power 1. Yes, the same base, x to power 1 times x to power 3, add the powers 1 plus 3, 4. Okay, minus 3x squared times x squared x to power 4. Okay, minus now times minus positive 3 times 3, 9, positive 9 x squared over x to power 6. I think here that's given here 2x minus 3x power 4. I think negative equal negative x to power 4 plus 9x squared over x to power 6. Maybe do simplification here. I think we can write here, this is take x squared as a common factor here, negative x squared plus 9 over x to power 6. We can do cancellation here, x squared and x squared from the denominator to get it. I think here 9, just order 9 minus x squared over x to power 4. This is f first derivative of x. That's good. Now make the first derivative of x equal 0. That's here 9 minus x squared equals 0. That's mean this is quadratic identity, 3 minus x times 3 positive x equals 0. We get it here two values for x, make the first derivative equal 0, x equal 3, also x equals negative 3. These are critical number, and also we have the third, x equals 0, that is make the first derivative is undefined. This is okay, make this is makes f prime of x is undefined. Okay, we have three critical numbers, x equal 2, 3, minus 3, also 0. Okay, now recognize here the table to study the sign to determine where is the function is increasing or and decreasing. Here x from negative infinity to positive infinity. Here this is the first derivative. The first derivative of prime of x is equal 0 at negative 3, also at 3, but at 0 undefined. Put it to parallel line refer to undefined at this point. To study here the we can take checkpoint here between negative 2 in this interval. Also we can take another checkpoint here between 0 and 3, we can take 1. Also here we can checkpoint, we can take 4 in this interval here. Also we can take a negative 4 as a checkpoint to determine what the sign in this interval, positive or negative, to know where is the function is increasing or decreasing. Let's see here, just substitute in the function the equation of the first derivative. The first derivative here negative 9 minus x squared minus 16. I think this is negative, this is here negative, but here if substitute negative 2 to power 2, I think 4, 9 minus 4, 5. This is already always positive, this is positive, I think. Also we can here substitute 1, 9 minus 1, 8. This is positive, also don't change the sign here, the same. Okay, but is put it here for, I think this is negative. This is here decreasing, then increasing, also increasing this in this interval, decreasing this. Okay, the next step, I think fourth step here, to find the second derivative of x, but here I think this is local maximum, sorry. Okay, the second derivative we can write here using quotient rule also. Here this is 9 minus x squared prime times x to power 4 minus x minus okay, 9 minus x squared prime times x to power 4 minus 9 minus x squared times x to power 4 prime. This is over x to power 4 times squared. This is quotient rule. Okay, we can simplify this. Also here, yes, I think negative 2x times x to power 4 minus 9 negative x squared times 4x to power 3 over x to power 8, because 4 times 2, 8 power to power times. This is, I think here, this is equal negative 2x to power 5, because here 1, add the exponents here. Here negative, yes, this is times negative 36 x to power 3, yes, negative here times, I think negative positive 4 x to power 5, 4x to power 5 over x to power 8. That's it here to continue. I think this is equals, I think negative 2x to power 5 plus 4x to power 5. This is equal to x to power 5 minus 36 x to power 3 over x to power 8. We can take 2x to power 3 as a common factor here to get it here. X squared minus 18 over x to power 8. We cancellation here also. You see x to power 3 from x to power 3 here to get it. I think 2x squared minus 18 over x to power 5. X to power 5. That's good. Yes, this is make the second derivative equal 0. Second derivative equals 0 to determine whether the function is concave up and concave down. That means 2x squared minus 18 over x to power 5 equals 0. That means 2x squared negative 18 equals 0. Okay, divided by, so both sides over 2 to get it. X squared minus 18 equals 0. This is equal x negative square root 18 times x plus square root 18 equals 0. We get it here. X equal square 18. This is equal, I think, 3 radical 2. Also x equal negative, okay, square root of 18. This is negative 3. Okay, radical 2. That's it. Is good. Also, we have here as x equals 0, makes f w prime of x is undefined. Okay, to put it here, this is the x from negative infinity to positive infinity. Here we negative 3 root square root of 2, 3 square root of 2. This is 0 here. This is undefined here, but this is equal 0, 0. This is f w prime of x. We can check. Take here, this is the point here, and check point also here to check. I think here we can write, this is I think, sorry, shift 9 3 equal, yes, okay, the, I think 2 alpha x squared is minus 18, okay, over I think x to power 5. This is calc. Here maybe take negative 6 here, and this is negative here, negative, maybe take negative here, negative 6 as checkpoint here, maybe take between this, maybe negative 1, take negative 1 here, yes, calc negative 1 to get it positive here, yes. Also here we can take between 0 and 3, maybe 1, yes, also calc 1 to get it here negative. Also the last calc 6, this is equal positive. Okay, this is concave down, concave up, concave down, concave up. It is good here. This is okay. This is at negative 3 root square root of 2 inflection point, and this inflection point, that's good. Also the last, I think here, just lim of x as x approaches to positive infinity, this is equal x squared minus 3 over x to power 3, lim as x approaches infinity, this is equal 0 because the degree of the numerator less than the degree of denominator. Also lim of x as x approaches negative infinity equals lim x squared minus 3 over x to power 3 as x approaches negative infinity equals 0. The last, I think, step here, y intercept here, make x equal 0. Okay, but x equals 0, I think here x equals 0 don't belong to the domain. Okay, outside of the domain. Here x intercept, okay, make y equal 0. This solution, that's x squared minus 3 over x to power 3 equals 0. That's mean x squared negative 3 equals 0. This is x squared equal 3, then x equal positive negative square of 3. This is the point here, negative third square root of 3 0, also square root of 3 0. This is 2 points that, okay, after determine all the features of this function, we can see the graph. This is the graph. If you see here, this is concave down from negative to this point. This is concave up. Also, this is y-axis is asymptote, vertical asymptote to here. X-axis is horizontal asymptote at infinity. This is here lim of x when x approaches infinity, positive infinity, 0. Also here 0. Okay, when the approaches this x approaches the 0 from right, the line go down, negative infinity. When approaches to 0 from left, the line go up. That means the positive infinity. Thank you for watching this video. We'll see you inshallah in the next